We're beginning Chapter 8 now, and then starting in Section 8.1. Well, Chapter 8 are methods of counting. And some probability. We just got through learning about probability. And this will help you understand some of the advertising you get on how many ways you can order a drink from Sonic or how many ways you can order your hamburger at Whataburger, which used to be a very big thing, that computation. So in this case, we're going to start first with the multiplication principle and then followed by permutation. So here we have a diagram, and we have two sets. We notice that we have the pastry. Make sure you can see it. That is comprised of B, M, and D. And then on the next one is beverages. And we have C, and J. All right. Coffee and juice. All right. So we have all of these. And this is all of the ways. This is called a tree diagram. That outlines all the ways you can order. A pastry and a beverage. So we can see at the end we have 1, 2, 3, 4, 5, 6. 6 ways. Well, we notice that the cardinality of our P times the cardinality of our B gives us that number, because we have 3 times 2, and we get that 6. So this is our first exposure to the methods of counting known as the multiplication principle. Principle has 2 or more mutually exclusive in other words, they don't share anything, elements that can be paired tree diagram to count the different types and quantities. The book had an elaborate, I don't think I wrote it, no. It had an elaborate description, but all you need to know is that you take the cardinality, that's at N, of set 1 times the cardinality of set 2 plus all the rest, and you get total number of ways to, well, I guess you could say all the ways to choose from. That's what I'm going to do it. Because we do this counting principle to figure out what we want from the listing on the menus, on the counters, all of these things, because it is a natural act for us. So let's look now at an example. Here we go. A menu offers a choice of 4 salads, 6 main dishes, desserts, how many different meals consisting of 1 salad, 1 main dish, and 1 dessert are possible. Well, we don't want to do the tree diagram, so we want to just state total different meals equals 4 for the salad times 6 for the main dish times 5 for the desserts. Well, 5 times 6 is 30. 30 times 4 is 120 ways. And this is to order 1 item from each um, uh, choice, each menu item. All right. So nothing hard, but we want to make sure that you understand the information. So we have that. There we go. On this next example, it says a couple has narrowed down the choice of a name for their baby to 3 first names and 4 middle names. All right. So let me make some room here. It's kind of cramped. All right. And how many different first and last middle names can be arranged are possible. So we're going to use again our multiplication principle. And we're going to take the 3 times the 4 and get 12. All right, 12 ways with just the selection of 3 for the first and 4 for the middle. So let's look at this guy. Well, now we're going to consider what if we only have 1 set of elements to arrange in an order. Now, this is going to be very important. Well, this is known as a factorial. A factorial has a symbol of an exclamation point afterwards. So these are some knowledge of it. So if I had 4 factorial, that means I would have, starting with the 4, times the 3, times the 2, times the 1, which is what they're explaining right here in this description. So then I would know then that 4 factorial means multiplication of all numbers leading back to 1, because you can't have negatives. That would be 4 times 3 is 12, times 2 is 24, times 1 is 24. All right. Now, the other caveat is that the 0 factorial is always 1. That it'll come out on your calculator, and it just goes to show you how a factorial works. That there would be, since it's none, we have one way of doing none. All right, I know that's a hard concept. So we want to evaluate the factorial for 5. So 5 factorial equals 5 times 4 times 3 times 2 times 1. All right, well, this is 20, and this is 6, right? So 20 and 6 is 120. All right, now you're guessing, well, I know there has to be a way of doing it on a calculator. Hey, and sure enough, there is. All right, so our first step is to enter 5 on home screen. All right. So I'm going to clear my stuff, and I'm going to put the 5. Okay, our second step is to find the math key. It is the third row, first key. Right, spells out math. So I'm going to hit the math key. Then you arrow over to PROB, probability. So I'm going to arrow over. There it is, probability. They make a little bit more room. And our fourth step is choose number 4 and hit the enter key. All right, so I'm going to hit the 4, goes back to the home screen and hit enter. Did I get 120? Yes, I did. Very good, class. Okay, now we're going to do the following with that process. All right, here we go. Let me make room on the bottom, not on the top. All right, so I'm going to clear it. I'm going to enter what? 6. I'm going to hit the math key. I'm going to do PROB, and I'm going to do number 4, enter. And it looks like 720. Right? All right, 720. Good. Okay, I'm going to hit the 10, the math key, PROB, and do our number 4 and enter. 8, 3, 6, 2, 8. 800. All right, very large. Well, you can see that a calculator can only place 10 digits in the screen. How many do I have? 1, 2, 3, 4, 5, 6, 7. Ooh, okay. Well, can we do 13? Let's see what happens there. 13, math, PROB, and I'm going to do the factorial and enter. Oh, I did it. So on this one, I have 6227 0208, and it looks like an 8 to me. 00. Alrighty then. So we've reached it. That's 10. Now, what happens if we do 15 factorial? Let's do it. 15 math. And what happens on what you see? PROB. And we're going to do number 4 and enter. Look what happens. We have this number right here. So if I did 15 factorial, I would have an approximation of 1.3076, blah, 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 and then e to the 12. And sorry about the 12 there. That means that it's in scientific notation. So big that it is 10 to the 12th. And that's only an approximation, because we would have to look at things differently. Right. Okay, so now let's look at what happens if we only want part of the set used. And that's known as a permutation. It has the n, which is the cardinal number of the set, and then it's going to have r, the size of the arrangement of a subset of n. In all cases, it's only one set. Data or elements, because again, we're in a statistical analysis type consideration. So here is what the book says on permutations, and I've just explained what I think would make sense for you. It says a permutation is an arrangement of elements where r elements are chosen from a set of n distinct elements. Repetition of elements is not allowed. Very important. Repetition is not allowed. I forgot to mention that. And the order of the elements is important. So if you're writing notes, you must state that order is important. If the probability of n elements of r size is the number of permutations of n elements taken r at the time, where r is less than or equal to n. Now, in a subset, you can use all the elements just instead of just going with the permutation. So here is the formula. It assumes that n does not have any repetition. So n factorial divided by n minus r in parentheses factorial. And that gives you the total quantity. All right, so let's do one without the calculator first. So here we have P of n and 2. So we know several things already. N is 10, and R, the size of the subset, is 2. So we're going to put it in the form of P of 10, comma 2 equals 10 factorial over n minus 2 factorial. Now, what I'm going to do next is how I did it going to school. We know that this is going to be 10 factorial over 8 factorial. So I'm going to put 10 times 9 times 8 factorial over 8 factorial. Well, now I can see that those cancel. And then I have how many? Yeah, buddy, I got 90. Ways of organizing two. To write that down for you. To arrange two elements from a set of 10 in unique placement. All right. So now let's talk about our calculator. In our calculator, it works on the premise that P of 10, 2 becomes 10 P2. This is how it's structured. That the N value is first, the P command, and then the 2. So now that we know that, we're going to, before we do it together, we're going to give you instructions. So our first one is to construct permutation in an NR form for your notes so you'll know what is needed. Our second step, on home screen, place value. All right. Then we do what we did with the permutation. The math key, arrow over PROB, and choose number 2. Yeah. And choose 2. And PR. And then we enter the R value and enter. All right. We're going to check our math. He's checking my math. So here we go. Ready? So I'm going to be on my home screen. I'm going to clear everything. Now I'm going to enter the 10, math, PROB. I'm going to do number 2, and then I'm going to enter 2 and enter. 90. See, we matched. Good job. All right. Now we're going to do another one without the calculator. And it says, no matter what n value, and we want 0 of it. So this means NPO. Well, anything like that is going to be 1 because we don't want to choose any. There's only one way in choosing none. One way. So there you have it. And then we have this one, NPN. All right. So what happens there if we're only choosing one? So this one is going to be N, whatever it is. So I have 5P1. There's only 5 ways to select one from the set. All right, so now we learned several rules. And we learned the calculator. So now let's apply it. And we're reading now for context. We're wanting to see if it's a specific order. Remember, a permutation is a specific order. So let's read. In a club 18 with 18 members, so my N is 18 members. How many ways can a slate of 3 officers consisting of president, vice president, secretary, and to be chosen? Well, if we want that, we understand it's a unique positions, and you can't have one hold 2 offices. So in this case, we're going to use the permutation. So we're going to let it be 18P3 to figure out how many ways they could select. So I'm going to take my calculator. There it is. I'm going to enter the 18 math, PROB. I'm going to choose number 2 and do 3. Looks like 4896. So we've got 18 members in a club, and there are 4,896 ways those members can choose, can be chosen to hold offices in this club. All right. Find the number of distinguishable permutations of the letters in each of the words below. So now we're going to have to include adaptation to repeating letters. And that means the adaptation to the permutation is because we can't distinguish one A from another A because they're all A's. So because of that, we're going to use division of the permutation by the factorial of the repetition. So if something's repeated twice, it's a 2 factorial. 3 times 3 factorial. So we'll do that on this exercise. All right. So we're going to do A first. And the letters are T, I, L, T, E, and D. All right. So in this one, we have the T repeated twice, and everything else is okay. All right. So our first step is find the cardinality of that set. So we have 1, 2, 3, 4, 5, 6. All right, I got 6 of those in that letter. And then we need repeated. So that would be the T is repeated twice and everything else is okay. All right, so now we're going to set up the problem. So this is going to be 6 factorial, because that's what we're doing, divided by 2 factorial. All right, so let's do that. Or we could do 6 P6, order important, divided by the 2 factorial. Both of those would work. So let's do it. So I want the 6 math, PROB, number 4, divided by, and this one is a 2 math, PROB, and we know that's a 2, but we're going to do it anyway, just so we keep it in the way we said. And we get 300